Hello and welcome to another episode of the skeletal system. Today we'll be continuing with the skeletal system part 2. In the earlier days, that is in the last episode, we have completed what we have said, that appendicular skeleton 126 bones and axial skeleton it is 80 bones. Clear? So this constitute the skeletal system of course it is human skeletal system. And here in appendicular skeleton the forelimb has 32 into 2 and these constitute 126. And here itself in axial skeleton we have said that there are three. Number one is skull, 29 skeleton, vertebral column 26, and thoracic case consists of 25. 80. So these constitute 80, these constitute 126. This much we have completed. Now, out of this skull, we have divided the skull into A, cranium, consists of 8 bones, and B, face consists of 14 bones. The 14, 8, 22, it should be 29. Three bones on each side. In this year, we have 3 bones, malleus, incus, stapes, and in this malleus, incus, stapes, there are 6 bones, of which the stapes is the smallest. So these 3 bones constitute malleus, incus, and stapes on both sides. 3 into 2 is equal to 6, of which the stapes is the smallest bone of the human body. Sometimes question may be asked, then you will simply write that stapes in the ear bone is the smallest and femur is longest, that will come. So these 6, the 46, 20 and 28, it should be 29. So another one will be there. Hyoid bone. 1. I am coming to hyoid bone. One after another. What we have said in skull, in cranium, 8 bones. What are the 8 bones? Frontal, parietal, frontal 1, parietal 2, occipital 1, temporal 2, Sphenoid 1, ethmoid 1. 2 to 4, 5, 6, 7, 8. These are the 8 bones of the cranium. Now skull, we have come across that this face, whenever you are going to say about bones of the face, first you say these one, these two. These two is first face, say. These two are gyromatics, it forms the cheek. So there are two gyromatics. Zygomatic bone. Then after this, you say about the faces. Then these two, here is one is the upper jaw. Upper jaw. This upper jaw is known as maxilla. After the maxilla, there are some hard palate here. It forms the roof of the mouth. It is known as palatine. Palatine. Then you comes to lacrimal glands. There are two lacrimal glands on lacrimal bone. So how much it is coming? Zygomatic 2, maxilla 2, palatine 2, lacrimal 2, 2, 2, 2, 2, 4 to the 8. Then upper jaw, after the upper jaw, you come to this lower jaw. This lower jaw is the only single bone. This single bone, and it is the only movable bones. So it is known as mandible. One. Then after the mandible, you come to the nose. There are two bones here on the right side and the left side. These are two bones. Nasal bones. Nasal bones are 2 in number. Then there is one. This is cartilage, and after this it separates. There is a bone like plowshare, which I told you earlier. That bone is known as vomer. Inferior terminates, increasing the nasal passages. That is, two inferior terminates. How much? 2, 4, 6, 8, 10, 12, 13, 14. This 14. These are the 14 face bones. Ear ossicles, that is Malleus 2, Incus 2, Stapes 2, these 6. Then hyoid bone, where it is? Hyoid bone, simple. That is, we move our tongue. Tongue is open on third side, front side and two sides. It remains joined in the neck. So after the neck, there is a U-shaped bone. There is a U-shaped bone where the tongue remains joined. This is the tongue. Remains joined with this U-shaped bone. This is known as what I have said. This bone is known as hyoid bone. It is single in number. It remains joined with the tongue. This is tongue. And it remains joined with the pharynx also. So it remains joined with the tongue and here pharynx. So hyoid bone and ear ossicles, face, cranium, skull is over. So this we have come across, everything we have come across. So just a little recapitulation of the previous episode. Now we will go to vertebra first. Then after the vertebral column, we will come to thoracic cage. Vertebral column consists of 26 vertebrae. But we learn that vertebral consists of 33 vertebrae. Out of this 26, 24 are movable and 2 are immovable. Let us go through it first. The vertebral column starts from after the skull there is cervical bones. These cervical bones are 7 in number. So we write C1, there are 7 cervical vertebrae. First, we will go through that, we will come to 26. Then, after vertebra, there is thoracic vertebra. So, I am writing it at thoracic and there are 12 thoracic vertebrae. So cervical, thoracic, then comes lumbar. So we take it upward. Okay, I am writing lumbar somewhere else. There are 5 lumbar vertebrae and thereafter sacral. Five sacral vertebrae. Thereafter it comes sacral, then coccygeal, that is tail region. Then here it is 7, then it is 12, then it is 5, then it is 5, then it is 4. It is 33 vertebrae. So our vertebral column consists of 33 vertebra, of which this cervical coccygeal vertebra forms a single vertebra. It pertains to tail. And these 5 fused to form a single vertebra is called sacrum. Now it is coming, this is one, this is one. Then 26. It was 5 here, it was 4 here. During birth, we had all these vertebrae in the newborn baby. But afterwards, with the development, with the passage of times, it gets fused. So we are having 33 vertebra, of which we will count the 26. Now out of 26, these and these two are immovable. These cannot move. But above that, whatever vertebrae are there, that can move. So how much can move? 12, 7, 19 and 5, 24. These 24 are movable and these 2 are immovable. So out of 26 vertebra, 24 are movable and 2 are immovable. These are the vertebrae. Now let us go how the vertebra looks. During our discussion on brain, we have said that this is a brain and this is the spinal cord. This is the extension of these are the 2 lateral ventricles. This is the 3rd ventricle and there comes the 4th ventricle, and the 4th ventricle continues as spinal cord. Within the spinal cord there is 4th ventricle, that is neural canal. It contains CSF, and the outer side also have dura mater, arachnoid matter and pia mater. These 3 are known as meninges. Like our brain, the spinal cord also remains covered by 3 protective covering that called dura mater, arachnoid matter and pia mater. Of course, there is subarachnoid matter and subdural space also, which also remains filled with CSF. And so in this canal, neural canal, it is actually the continuation of the 4th ventricle. There also CSF remains, and this subdural space and subarachnoid space, they are also remain. Now it goes down through the vertebral column. So we know that this vertebral column, this is the vertebra, this vertebral column has some opening. Here the opening is known as foramen magnum. We have come across, we will discuss in detail today. And within this vertebra, there is a hole that holds the spinal cord. That is known as spinal canal. that is spinal cord remains suspended within this vertebra. Now let us take a look about this vertebra, how it looks. How it looks. Let us draw the vertebra first. A vertebra contains a central mass, it is solid. It is known as central body. This is central body or centrum. How it looks? Let me figure it out. Just a minute. So this is vertebra. This is vertebra. This is the central body. Of course, the white portion is not there, it is solid. White portion is there. So it is fully made up of solid articles, solid ossical bones or osteocytes. And then whenever another vertebra comes here, this centrum remains with the another, like this is solid figure. And here also remains another vertebra. This is solid foundation. In between there is vertebral discs, slip discs, vertebral discs or slip discs or intervertebral foramen. Then another vertebra is there above it. This is solid mass. And in between there is intervertebral discs. Intervertebral foramen, or these are called discs, or these actually if tilted becomes slip discs. So these vertebra, one upon another, these are solid mass. So it can hold the strength, the total weight of the body. If it is open inside, which I told you here, so it would have been some ring-like structure. So ring-like structure, if you put a heavy weight, that is 70 kilo, 80 kilo, it will break. So this is solid part. This is solid part like this. This is solid part. This solid part is known as centrum or body of the vertebra. Clear? Now from the solid part, on both sides of the solid part, here some growth takes place. That is like this. This is the solid part, and from this side one, and from this side two neural arch growths. Two neural arch. One from this side, one from that side. That is, from these two sides, two neural arch grows. Spinal cavity neural arches. So these are on the left, like this way. This is right, this is left. This is right neural arch, left neural arch. So these two arch grows, and they fuse here. They fuse here. They fuse here. So this forms a bony ring. This forms a bony ring here. This is the bony ring. This is outside the centrum. This is outside the centrum, and this is the bony ring like structure. So if another vertebra comes above it, the bony ring fits the another bony ring, then another bony ring, another bony ring. So it remains, forms a cavity. That cavity is known as neural cavity, and through which the spinal cord passes. So this is not within the vertebra, it is outside the vertebra. Let me give you another. Suppose this is a column of a house. This is a column of a house. It is a square. That is long cubical, big, and inside there are some iron rods are there. So this is a column. So above, on the side of the column, suppose this side, and making a tube like this, spinal cord. And on both sides, I am keeping some clamp on it. This is a clamp. I am fitting the clamp, iron clamp over it. So I am fitting it with the iron clamp so that the water do not get disturbed, and water goes out from here to here to here to here to here to up to the top floor for the tank. So water supply takes place not through the column, but on the side of the column there is a ring-like structure. With the help of this neural arch, it remains a long bone. One after another, it remains a long bone. This is known as neural canal. So neural canal is not within the vertebra, but it is formed by the outgrowth of the neural arch on the left side and right side. Clear? Now, this vertebra also has, this is central body or centrum, neural arch. Neural arch, whenever it is growing, it gives here a process. Spinous process. Just opposite the body. It is just opposite the centrum. So on the back side, it is front side. This is front side. On the back side there is neural canal, or after the neural canal it gives a process known as horns. This is known as spinous process, or this is called as spine. Sometimes we call it spine. As it goes through, it gives another process here, another process here. These two are known as transverse process. So in a vertebra, what we see, here are some processes. These are called transverse process, and on the back side, that is just opposite the centrum, there is another process known as spinous process. This process, actually whenever we take chicken chop, or whenever we take the mutton or like that, you will see there it is full of processes. So this is the spinous process, and these two are known as transverse process. Okay. Again, these vertebra should fit with this vertebra. This vertebra will fit with the another vertebra. So on the vertebra, this is solid mass. I am not expert in drawing. The solid mass, on the back side there is process known as spinous process, and on these two sides, on these sides there is another process, there is another process. Clear? This is not above, this is on that side, and above it remains flat. Now what happens? Whenever another vertebra comes here, it should have something for articulation with the previous vertebra. So it has one. These two processes, these two superior and two inferior processes. So these have superior processes. Maybe right or left, right, left, and two inferior processes. These two are inferior processes to fit with the next vertebra here. This fits here. It has also the superior process and superior process. These two fits here. These two fits here. So inferior, it has so many processes. These two are superior processes on both sides of the vertebra. This is the spinous process on the back side of the centrum, and two transverse process on both sides of the vertebra. So these two superior processes and inferior processes are meant for the articulation of the above and below vertebra respectively. Clear? Now, this is the structure of a vertebra. So we have how many vertebra? 26 vertebra. Originally it was 33, now it is 26. Now, question sometimes comes, what is the difference between cervical vertebra and thoracic vertebra. In the Bhagavathi, you may be asked, what is the difference between this cervical vertebra? How we will distinguish the cervical vertebra with that of the thoracic vertebra, which will come time to time. Now, we are in the vertebral column. The first vertebra, this one, it is a solid mass and it has, say this is C1, it is solid, centrum, and it has on that side one process, that is spinous process, back side and downward, it's a spinous process, and these two are known as transverse processes on the right side and the left side. Let it be C1 vertebra. Now, how will differentiate with the C vertebra and the thoracic vertebra? There is a special point for remember. It has the transverse process of cervical vertebra on both sides has some hole. It starts from C1 and it has the spinous neural arch. Neural arch also go there. Sorry. Neural arch from this side. Neural arch from this side. It produces that spinous process, and this is known as, this hole is known as, hole is known as neural canal, through which the spinal cord goes down. Now the spinous process, and this is the spinal canal. Here spinal canal and this neural arch have another outgrowth known as spinous process. The speciality of the cervical vertebra that it has on both sides of the transverse process some hole. This hole is known as foramen transversarium. It is foramen transversarium. Foramen means hole. Transversarium. So in C1, C2, C3, C4, C5, in what is called in the transverse process, of each vertebra, there is hole inside. There is hole inside. That hole is known as transversarium. From here, the vertebral artery goes down. So from here, vertebral artery goes through it on this side and their side. Likewise, vertebral vein also sorry, I don't have that color. So vertebral vein also passes through this. So it contains vertebral artery, vertebral veins, vertebral artery, vertebral veins, and it from here through the whole passes the nerves, sympathetic nerves. Through these transverse processes of the cervical vertebra, these three vertebral artery, vertebral vein and nerve, sympathetic nerve passes through. Now it is like this. Consider a motorcycle. And this is the handle. And on the after the handle, there is another like this, on that side like this. From here some wires comes out. It goes to indicators and brake wire and others. It passes through this side, it passes through this side. So whenever there is tilting, so the wire does not get hampered. If it is within this, then wire would have hampered, but on both sides there are some nerves, veins, and there are some artery, veins and nerves passes on both sides, which is available in cervical vertebra only, what is known as foramen transversarium. Clear? Through this is the typical of a cervical vertebrae. Clear? This cervical vertebra has this foramen transversarium. Now, we are with the vertebral column. This is the C1. This is the C1. C1 vertebra has another specialty. This C1 vertebra has another specialty, that is, its upper part is this, like this. It is solid mass. This is solid. And here the skull remain attached. Clear? The skull and the cervical vertebra 1 is having the joint of the how here on the back side we have come across that there is a flat bones which is known as occipital bone. This occipital bone is on the back and the ventral side. This occipital bone has a hole in the base. That hole is known as foramen magnum. So foramen magnum fits just on the neural cavity. Foramen magnum fits, and the skull remains within this vertebra, this C1 vertebra. This 3-1 vertebra is known as atlas. Clear? So it is the atlas, and let me just a minute. Suppose this is the skull. This is the what is called occipital bone in the base. Occipital bone is on the base. This occipital bone is flat here, and in this occipital bone there is a hole. That hole is known as foramen magnum. That foramen magnum fits over the neural canal, and the outside remains or rests on this cervical vertebra. But we move our head like this, like this, like this, like this. So whenever we move it, so there is a in this vertebra there is a friction. So if we started from our life throughout the up to death, we move our head in this way many a number of times. So there will be wear and tear. So wear and tear, to avoid this wear and tear, there is a special mechanism in this over the atlas. Let me draw it. Suppose this is foramen magnum. So I am taking this that way. This is foramen magnum. This is foramen magnum, through which the spinal cord will go, and this fits over the neural canal. Neural canal. This is neural canal, and this is vertebra. So whenever we nod, we move our head like this, like that. This should have friction over the atlas. To avoid this friction, it has two ball bearing. This is a ball-like structure. This is a ball-like structure which fits over this. So this should have some ditch like structure. How the ditch looks here on the right side, it looks like this. On the left side also of the atlas, this is over the atlas, above the atlas. There are some two ditches. These are called facets. F-A-C-E-T-S, facets. These two are known as, this is since it is in the here the this is known as foramen magnum. This is occipital bone. Occipital bone is flat. This is foramen magnum. It is the opening, and on the foramen magnum on both sides, here there is some protuberances like ball-like structures, say protuberances. Here also one protuberances. It should fit on the first vertebra. This is the first vertebra above, on upper side. It should have facets so that the ball can move to this side, to that side. The ball can move. Now this ball can move on this side and that side. So this is foramen magnum. So this should have some ditches. That ditches will allow the head to move up to this. So this foramen magnum, these two portions are known as, this is the opening foramen magnum, sorry, this is the opening, and these two are known as occipital condyles. This is known as occipital condyles. These occipital condyles, that is, it is ball. Write it in exam. Do not write ball. It is like a ball-like structure which moves here up to this and moves up to this, moves up to this, moves up to this. So it is the arrangement, and these two, the ditches, are known as superior articular facets. These two known are, write it down, superior articular FACETS. This is on the right side, right superior articular facets, and this is known as left superior articular facets. So it will move the occipital condyle. This is sometimes in the exam comes. What is occipital condyles? It is an outgrowth. It is a ball-like structure. It is a protuberance just on both sides of the foramen magnum, and it fits. Actually, it is the fitting point. It is ball-like structure. It fits with the superior articular facets. It is for articulation, and this is left for articulation. Now, one thing more. This is known as atlanto-occipital joint. This joint is known as atlanto. This joint is known as atlanto. Atlanto-occipital joint. This is the atlanto. I don't know how it has come. It may be because of this Atlantic Ocean is there. So Atlantic and occipital joint is known as atlanto-occipital joint. This is the joinings of the first vertebra with that of the skull. With that of the skull. Clear? Skull has this occipital bone which have some opening called the foramen magnum. On both sides of the foramen magnum there remains two ball-like structure. This ball-like structure is known as occipital condyles, which fits over some superior articular facets, and that's why it helps in nodding movement of the head. Sometimes we go to saloon and we used to advise them to do some massage or like that. They do like this, So do not do that. It's my request. Why? Because they do not know that how much they have to give pressure. And if this ball comes out of this, if there is any tiltation, a slight 0.01 millimeter defect in tilting of this, it will be like this. And in the same time, whatever arteries and veins are there on this transverse processes, that will also get defected. So your artery, the vertebra will not be supplying the food by the artery, as well as it will not drain out the waste product in the vein, as well as your nerve, sympathetic nerve will be defected, so you will be paralyzed. So in case of giving message, and don't allow them to do like this, because if it is more, it is very dangerous, because it may hamper your total vertebral column. Spine surgeon do, they used to take the structure here, length, breadth, height and others. They take of these occipital condyles and they take the measurement of these superior articular facets, that how much is allowable, and occipital condyles, what is the length of breadth and height at this is the height, and what are the nerves which gets impacted for this, and if there is spinal injury, then also this may happen and you will be called by the spine surgeon to fix you, and throughout life it may not, for the God's sake, you will be okay, but if there is a little 0.01 defect, you will have some these defect also. So up to this, we will come. I request you one thing, whenever you go to YouTube, you will see my face. In the right side there is a subscribe button. Now you just touch it, it will cost you nothing. It is free of cost. You just put a subscribe.